All right, so as I have said, this is basically review material that I'm not going to spend too much time, but the short summary of this review is that when you took your SPPH 400 and 500, all of the components that you have learned there, basically um, I'm talking about doing some sort of t-test or regression or some sort of ANOVA, whatever you have done, all of those were based on just this simplifying assumption that your data was coming from an infinite population. And there was some data generating process. Say, for example, you were assuming that your data was coming from a normal distribution, and all of the inferences that you do, all of the t-tests that you do, all of the significance tests that you do, all of the regression that you do were based on this assumption that your sample is coming from an infinite population, and that infinite population is being generated from a normal distribution, right? So that was the main assumption under which you were operating. So in this course, we will deviate from that assumption to some extent. And before I explain about what is the design-based approach, let me explain some of the basic ideas of how a sampling is done. That will be helpful for you then to understand what is this design-based approach. So think about when, say, for example, Canadian government is interested to know what is it that is happening within the Canadian population, so that Canadian government can make some decision about what is the need. Say, is there any health disparity, whether some particular group is not accessing healthcare or things like that. So if the government wants to know about their population, then what they do is they try to sample from that population. But as you know, simple random sampling is a sampling design, and that is quite easy to design, but it is very hard to implement if you have a very large population. Say, for example, if you have this Canadian population, and then you are trying to do a simple random sampling, logistically, that will be very hard. So what they try to do is um, they try to first think about a target population. So you can think of the target population that you define in your PyCode. The P stands for population, right? So you need to have a target population to which you want to generalize your results. And say, for example, for the CCHS, the dataset or the subpopulation that you are basically interested about is the population that are of age 12 or older, because less than 12 years of age has much less to do with policy, but there might be some policy implications collecting those datasets, but releasing those dataset to the public is one concern, and another concern is that that population might not be able to provide proper information that we need to collect this data. So assuming that this is your target population, that Canadian population, 12 years old or over, you want to sample from them. But there are some issues. Say, for example, there are some segment of the population which is either not accessible, or for Statistics Canada to gain access to that data, they need to go through additional process. So, for example, for the people who are in the Canadian forces, for the people who are institutionalized in the foster care and things like that, there might be some restriction for Canadian government to collect or release those type of documents. So usually there is a difference between the target population and sampling frame based on who is accessible or not. And then even if you have a complete sampling frame of people who are excluded, by some of these specific criteria, there might be some people who have already died, so they might not be reachable anymore, or they might have moved to another province or things like that. So within a province, that person is probably not reachable anymore. So that brings us to this active frame. So this active frame will consider only those people who are reachable within your sampling frame. And then within that active frame, you will have some sampling list where you can create some sort of sampling out of different type of sampling techniques. And then even if you send them a question, that does not mean that they will answer those questions. There might be some non-response, and you will get a subset of those population who will answer your question and who will become your actual sample, right? So thinking about your original target population, you lose some people in your sampling frame because, say, for example, they were in jail and their data could not be collected. And then you lose some other people who are not active. Maybe they are dead, maybe they moved out of province and things like that. And then you have create a sampling list out of this active frame. And even in this list, even if you send the questionnaire, some of them cannot answer or do not answer, and they and you get a non-response from them, right? So when you are generalizing this result, you are obviously aiming for this result to be generalized to this target population, but along the way you are losing a number of people. So when you are generalizing, it is always helpful to think about who is it that you are missing, so that will be useful for you to interpret about the result and make the generalization about the population. So in here, I talked about some of the sampling based on which you prepare your sampling list, right? So what are those sampling techniques that you can use? In general, there are two different types of sampling technique. One is the probability sampling and one is the non-probability sampling. So the non-probability sampling is based only on convenience. So say, for example, you are in a mall and you are trying to collect some information. You just ask around and some people answer your question or not. And that is based on no probability distribution. But to properly do a sampling design, you probably need to deal with a design that that knows what is the probability of being selected. And that probability has to be known for you to calculate all of the subsequent inference results, such as the target parameter, the confidence interval, and the standard errors properly. So within this probability sampling, you have this simple random sampling, stratified sampling, cluster sampling, systematic sampling, and some sort of mix of cluster and stratification, which is known as the complex sampling. And obviously, there are some other non-probability sampling based on convenience and things like that, like quota sampling. And we are not really particularly interested about these kind of sampling in our course. In this particular course, we will be focusing on this probability sampling portion. All right, so that brings us to the difference between the model-based estimate and the design-based estimate. So the model-based estimate that you have been dealing with in your SPPH 400 and 500, we're always assuming that you are dealing with an infinite population, and it follows a distribution such as normal distribution. And then you can use some sort of sampling design to infer about that infinite population from the sample that you receive. But the design-based approach is somewhat different than model-based approach. And the difference is that now you are assuming there is a fixed population, and that population is finite. Though there is no infinite component in here. It can be a large number, but it has to be a finite number. Say, for example, when you are dealing with Canadian population, it can be a large number of population, but it is still a finite number of population. It is not an infinite population, right? And also, we are not essentially generalizing these results to any other population outside of this Canadian population. So when you are making inference from a CCHS data where only the Canadian population data is collected, you are not going to make an inference about US population based on this Canadian population. That is not simply what we do. We do not really care about external generalization. We are only caring about one population, and that is why our population, the generalization population, is a fixed and finite population, and that has some consequence. All right, so there are some characteristics that are essential for a design-based study. The first characteristic is that you have to have some sort of probability which is not zero for being selected in the sample, and that probability has to be known. So as a designer, as a sampling designer, you need to know what is those probabilities exactly, because in the later on we will see that these probabilities will be used in calculating many of the different things that we need to establish our inference. And not only the probability of one single person, we actually need to have an understanding about what is the probability. Every pair of subject must have a non-probability, and that is known as Pij, and that probability has to be known as well. And that will become apparent when you will see some of the sampling that we do are not independent. If our sampling was done independently completely, then probably only this probability would be good enough to calculate our inferential components. But since we're dealing with a dependent population, I will explain it why that is the case. Then we need this kind of probability of a pair being selected. All right, so there are obviously simple random sampling is one way to sample. Cluster sampling is another way to sample. Stratification is another way to sample. But sometimes it is necessary to combine all of these type of different sampling in your sampling design, and that is known as complex survey. Just to give you an example of a complex survey, probably it is helpful if I give a very concrete example of what is happening in NHANES and how do they do their sampling. So say, for example, NHANES dataset is has a long history of collecting their dataset by the US CDC, and there were many phases of data collection in earlier years. But from 1999, NHANES has been regularly collecting these datasets in a very specific format, and that is known as the continuous NHANES. And from that, we are going to focus on NHANES 2007-8 dataset. This is one cross-sectional dataset that we are dealing with here. So in that cycle or the year, so these years are known as cycle in the NHANES, we have 10,000 individuals, and there were many phases of sample collection. So usually everybody participated in everybody of these participated in a in-home medical history interview, and there was a medical examination part going to the lab, and the patients were giving samples and the participants were giving samples. But that was another layer of the interview. But for the purposes of today's lecture, I'm just going to focus on this in-home medical history interview. So this sampling is done in 4 different stages. And in the first stage, you have to understand that this is not a simple random sampling. If this was a simple random sampling, then people will be eligible to be selected from everywhere, and sending interviewer to everywhere is not logistically possible. And that is why we need to come up with a very complex plan where the statistical analysis might be very difficult, but the collection of the data will be very easy. So how do they do that? So this primary sampling unit or the clusters are the very smallest amount unit of sampling. And how are they created? They are created by counties. So US has 50 states, and they are divided into 3,100 counties. And then those counties are usually assigned to a strata, and that strata could be determined based on whether that is a rural area or urban area, or depending on how large is the county. And then a simple random sampling is conducted based on PPS. That means that the sample units that has larger population are more likely to be selected than those that are with smaller population. So this is a complex process. So in the stage one, what they are doing is that they are essentially dividing all of the states into counties, around 3,100 counties, and they are assigned to a specific strata. So in here, they are using the idea of cluster sampling, and in here, they are using the idea of stratified sampling, right? So they are combining and making it a complex sampling to begin with. And then they're using this PPS sampling to randomly select which particular county will be selected. And then we have this is the most complex slide of this lecture, I guess. So in the second stage, you can see that each of these counties that are selected in the stage one, they are broken into segments. That means with at least 50 to 100 housing units are called a segment from each of these counties. And then they are randomly selected. And in the step three, within the selected segments, we are dividing them into households, right? And those households are then randomly selected. And then in the step four, what we're doing is that within each of the households that are selected, we are randomly selecting an individual from that household, right? So as you can imagine, in the stage one, we are already doing a multi-stage sampling design. A complex sampling design using the idea of clustering and stratification. And the stage 2, 3, 4, we are simply consecutively going down the list to sample in a more granular level. So just to summarize that, you can see the strata and PSU or the clusters are determined in the stage one, and then we determine, then we select some PSU. And from those PSU, we select some segment, which means some household units together. And from those segments, we select a household, and from those household, we select an individual in the step four. Cluster is basically the counties, whatever counties you have in your, and that was based on dividing all of the 50 states into counties. I think counties are already defined, which geographical area belongs to what county. And then strata is more about the homogeneity. Like if some rural areas are together, then we can combine them together. If some urban areas are together, we can combine them together. So in a sense, you are right that when we are creating this strata, we are trying to create them with the sense in mind that the population within a strata will be homogeneous to some extent. All right. So obviously, it is a very complex sample. So that means what? That means every person in this sample do not have the same probability of being selected. If that was the case, then we would simply do a simple random sampling, right? Because since we are doing our sampling in a very complex way, our probabilities of getting selected for each individuals are not the same. But even though they are not the same, we exactly know what is that probability of one person being selected in the sample. And this sample is unlikely to be representative of the entire population because there are some oversampling and undersampling going on, because government wants to know what is happening with some of the key populations. Say, for example, if you want to know more about the African Americans or the Mexican Americans or the low-income white Americans or person age 60 years of age, or if you have these targeted populations in mind because you want to make some policy decisions about those populations and you need to know what is happening with that population, you will do some undersampling or oversampling about them. So say, for example, for the Mexican Americans, they are usually oversampled so that we can collect more information about them. And also samples are dependent in the sense that when we are dealing with these clusters, so as you can imagine, if one cluster is selected in step 1, all of the stage 2, 3, 4 population are coming from that one PSU or the cluster. And so in the first stage, whichever cluster was not selected, none of the populations are has any chance of getting selected in that population. So as you can imagine, the people from the same cluster are having same sort of experience because they are geographically living closely, right? So the sampling is not going to be independent in that case. The samples are going to be dependent, and we need to use these probabilities to deal with that unequal probabilities. All right, and you will see, because remember in the NHANES 2007-8, we collected only 10,000 interviews, right? But that is not the entire population. We need to also connect or map our sample to the population. And how do we do that? To do that, one instrument is the sample weight. And say, for example, in the data set, you will see there is a weight assigned to each of the persons. So for example, a person's interview weight equals 50 would mean that that person represents 50 other people in the target population in the US. What was our target population? The US population, right? Within certain age range. So if someone's interview weight was 50, that person would represent 50 other population in that sample. And the calculation of this weight in the simple random sampling is very easy. It is 1 by probability of getting selected. But in our case, when we are dealing with a complex survey, then we have a lot of the different components and formulas that help us create these weights. Some of these components are unequal probability of selection, non-response adjustment, because there will be some non-adjustment. Just because you send an interviewer does not mean that you will get that respondent. And also adjustment of the independent population controls. So there are some other additional components that goes into the sample creation, and all of these concepts are used in the weight calculation so that you can properly represent how many people are being represented by this one respondent that is being selected in the population. All right, so we have talked about interview weights, we have talked about strata, and we have also talked about the PSU or the cluster. So these strata and PSU are something that you determine at the stage 1, and this interview weight is something that you determine at the end of your sampling. And if you go to the NHANES website, if you go to the data dictionary, all of these values are calculated for all of the population that are in the sample. So if you have 10,000 population in your sample, say for example, we had 10,149 population in the sample, you will calculate weight for each of these persons. And then you will have strata and PSU for each of these persons because they have to belong to some particular PSU, right? Yeah, that. So what I want you to do is that this is a very detailed documentation of the steps of how you can download a CCHS dataset from the UBC library. And at the end of the downloading and conversion, you can incorporate that dataset into your R. So these very detailed steps are already given, and I want you to try out downloading at least one cycle of CCHS data and try to figure out whether you can do it, because this is the first step of your final project, learning how to download the file. And in the next week, what we will do in the next week's lab, when you download the files, after downloading the files, how to create the analytic sample. And similarly, you can also download the NHANES file, and there is a very detailed instruction given. And fortunately for NHANES, you do not have to go through that much step. It is openly available, so you can simply download that. Even there is a R package. There is a R package called Enhance A, and there is another package called R Enhance. If you specify your parameters correctly, if you just specify which year data you want to download, you can download that in one command. So that is that simple. And I think it is very good idea to go through this enhanced introduction section as well. That will give you some idea about how the documentations and the data are structured. But to give you a very brief idea, in the CCHS data, when you download the data, that data is downloaded. There is nothing to merge or append or anything, because that is your entire data set, right? That is your CCHS data, one data. But since there is so many questions in the enhanced data set, and there are so many people that are being sampled in the enhanced data, they do not have all of the data in one data set. Say, for example, your demographic data will be in one data, your dietary data will be in another data set, your examination data, physical, dental, that will be in another data set, your laboratory data will become saved in another data set, and your questionnaire data or the household interview data will be saved in another data set. So you can see if same person can contribute to all of these 5 different components. So even though downloading the data is easy, but the one more step needs to be done for compiling all of this data is then you have to, there is a unique identifier number for each of these patients that is available for each of these data sets. Say if I'm talking about one particular person, that person will have the unique identifier number same for all of these data set, and you can, based on that unique identifier number, you can merge all of these data set into one analytic data. So in the next lab, I will actually show you how to do that. But I think it is a very good idea to go through this enhanced page to get some idea about how the enhanced procedure is done. Basically, this describes the 4 steps in a very detailed way, and it might be worth thinking about what is the sampling weights and oversampling and things like that. The other part I just want to show how much time I have. 2 minutes, okay. So in 2 minutes, I'm just going to show you how to figure out what is it that, like, say for example, I am interested about arthritis, and I want to find out, because there are so many data sets, and which data set to download, I don't know, right? So I just search this, right? And then field to search, I want to say search all field, all variable names, limited no. And I just want to select within the last cycle, right? I search, and that gives me, it found 4 within that 2017-18 cycle, right? So I'm just trying to figure out whether I have, say for example, my exposure variable is rheumatoid arthritis, say for example, right? And I'm trying to find out whether, which type of arthritis was it, right? So that question was actually asked. And this is the data file name. So it says medical condition. There is a data set called medical condition, and there I can have the answer for this question. So I go to this questionnaire, and which was it? Sorry. Of course, I'm not going to get any answer. The spelling was wrong. Yeah. So this was, oh, another thing I need to determine is this. So this was in MCQJ data. So every year is associated with one particular letter. So 2017-18 was J. So there is a document and there is a data. If you download this is the whole MCQ data set that you download. And that can be done using R as well. But this is the documentation that you need. And you are interested about what? So see, there is the, so this is a table of content, and in that table of content you can search. Doctor ever said you had arthritis, which type of arthritis was it? So you go to that. So this is the variable that contains the information about how many people have arthritis or not, right? And say, for example, you want to figure out how many of these arthritis patients have cardiovascular events. Say, for example, if there is any heart attack event. So ever told you had coronary heart disease. So there is another variable that contains that information. And if you download two of these covariates or the variables, then you can make a cross tabulation to figure out how many of the people who have rheumatoid arthritis has this coronary heart disease. One question I need to stress is that so when you are asking the exposure related question, that has to happen before your outcome, right? But this is a cross-sectional data. Is there a particular way to determine whether this heart attack or this heart disease happened before you had your rheumatoid arthritis or after, right? Just based on this variable, it is not possible. But you might get lucky sometime, because there is another question, age when you are told you have coronary heart disease or not, and there should be another question, age when you are told whether you have rheumatoid arthritis or not. So based on that, you might be able to figure out that, but you might not be lucky all the time. So this is a cross-sectional data, and that might not be possible all the time.